Hi everyone, welcome to part 2 of lesson 5.1.2, marginal, joint, and conditional probabilities. We're going to now investigate joint probabilities, and we're going to still be working with the same census data that we had used for the marginal probabilities that we were looking at. So essentially what I want you to note is it's depending on whether you are asked to do a conditional probability, a joint probability, or a marginal probability, it's going to depend on how the question is asked. So you might notice, for example, like we did in the previous video, that you are dealing with a marginal probability when all the numbers that you are kind of seeking out or pulling from that table are existing in the margins of the table. So now what we're going to go ahead and do is we're going to take a look at question number 6 in your packet. So this question reads, and bear with me while I write it in, what is the probability that a randomly chosen adult is male and has never been married? If we wanted to kind of notate this, so use that probability notation, we would use P to represent probability, and then we would write in male and never married. So we have these two pieces. This is essentially what makes it joint. So if you kind of think of a joint, so I know that I keep referencing this idea of like your forearm, so like how the elbow is a part of that. So if you think about it, your elbow, it has a joint that connects the forearm to the upper arm where your bicep and tricep are. So you can kind of think of a joint problem whenever you have an and in there. So you're combining two things and holding it together with that and, that word and. So this is how we know we are dealing with a joint probability. So again, in this case, we want to ask ourselves, well, who are we going to ask this question? So again, if we go back to the top one, we're saying, what is the probability that a randomly chosen adult? So we just want to ask adults. And again, recall that this table is filled with just adult responses. Thankfully, we do not have any children in here who are married. So again, our result would go to that grand total. The people that we're going to go to is we're going to go to all adults from the data that we collected. And then we, instead of asking one question, we're going to ask them two questions to kind of figure out if they're going to come along with us in our numbers. So we are going to ask them, hey, can you tell me, are you male and have you never been married? So in that case, that means that our winner here is going to be that 33.7 million adults. Those specific 33.7 million people are male and have never been married. So from here, again, we would go ahead and come up with that probability, and we're just going to leave this in its decimal form, rounded to the third place. So this is going to come out to 0.147, although if you did say 14.7%, that's also acceptable. All right, so let's go ahead and take a look at 7 next. So I'm going to go ahead and clear my board, and let's go from there. So for question 7, it says, if an adult in the US is chosen at random, find the probability that they are female and married. So again, in this situation, we want to say, okay, I'm noticing that we want to actually talk to every single adult in the US. So that's telling me that my pool that I'm going to go to is going to be the 229.1 million again. And then within there, we are essentially, you can kind of imagine yourself going up to every single one of these 229.1 million people, although that might actually take a while in real life. And you're going to ask them, hey, are you female? And this is important, so that word and, are you married? So again, the and is what makes this a joint probability. We are combining two pieces of information to get a specific person. So again, in this case, I would basically be saying, all right, I'm only going to concern myself with the female group, and then I want to look for the married. And where you see that overlap is who I care about. So in this case, I want to focus on the 65.1 million people. These are both female and married. When we go ahead and calculate this, we end up getting 0.284. So again, out of the grand total of this adult population that we surveyed in the census, we are finding out that 28.4% of them are female and married. Okay, so again, notice that nothing else kind of comes into play. Okay, and again, that joint is essentially where those two descriptors intersect each other or connect. So let's go ahead and take a look at number 8, and then we are essentially done with discussing joint probability. Okay, so number 8 reads, if an adult in the US is chosen at random, find the probability that they are male and divorced. So again, hopefully you've attempted this problem. If not, please, I would encourage you, pause the video, give it a try. But what we're saying here is, again, we're going to go to adults in the US. This is who we are going to go and ask the question to. And this might seem kind of overly simplified, but you can imagine that we could have blown this data collection out a little bit further and broke it down into all the different countries found throughout the world. We are just going to focus on the US. And it just so happens that all of our data is coming from US adults. So again, our total pool that we're going to go to will be the 229.1 million people in the United States. So from here, we can now go ahead and break into talking about, okay, everyone that I'm going to talk to, so the full 229.1 million people, I want to only look at the male group, and that's where my joint probability comes in, the fact that I'm using an and, so that's a key word. I'm going to ask if they're divorced. So we will come through here, and the winner, I guess if you want to consider discussing divorces winning, I don't know. We're going to find out that our winner, or our winning group, or the group that we're interested in, is going to be that 10 million group. So we're going to go ahead and drop in our 10 million. And then again, if we were to go ahead and calculate this, we end up getting 0.044. So out of our US adult population, oops, I'm putting in a decimal point where I do not need a decimal point, we get a probability of 0.044 or 4.4% if we converted it into its percentage form. All right, so this essentially wraps up some examples of what joint probability is. Essentially what you want to note here is you are essentially being asked to combine two characteristics when you are looking for the population or that group that you're most interested in out of that entire pool that you've set up. I hope that this has been helpful. Please let me know if you have any other questions.